Welcome to the basics of NumPy arrays. So data manipulation in Python is nearly synonymous with NumPy array manipulation. Even newer tools like pandas, we will discuss in the next section, are built around the NumPy array. This lecture and this section will present several examples using NumPy array manipulations to access data and subarrays and to split, reshape, and join the arrays. While the types of operations shown here and shown in the upcoming lectures may seem a bit dry and pedantic, they comprise the building blocks of many other examples used throughout the course, so get to know them well. We'll cover a few categories of basic array manipulation here, such as attributes of arrays, which is determining the size, shape, memory consumption, and data types of arrays. And then we will discuss the indexing of arrays, which is getting and setting the value of individual array elements. Then we will discuss slicing of arrays, which is getting and setting smaller subarrays within a large array. Then reshaping of arrays, which is changing the shape of a given array. Then joining and splitting of arrays, which is combining multiple arrays into one and splitting one array into many. So now let's move to the NumPy array attributes, which is our first basic array manipulation. Okay, so first let's discuss some useful array distribution attributes. We'll start by defining the three random arrays, which the first one is a one-dimensional, then two-dimensional, and three-dimensional array. We'll use NumPy's random number generator, which will seed with the set value in order to ensure that the same random arrays are generated each time this code is run. Starting off with the import NumPy as np.random.seed, we'll enter 0, which is seed for reproducing. The seed is for reproducing, and now we will x1 is equals to np dot random dot rand int random integer 10, which is one-dimensional array. This one is one array. x2 is equals to np dot random dot rand int size is equals to 3, 4. This one is two-dimensional. Ignore that. Okay, now x3 is equals to p dot random three, 4, 5. We skip the brackets here. delete the, okay, so now we have run this program. Now each array has attributes ndim, the number of dimensions, shape, the size of each dimension, and size, the total size of the array. So now we will write print x3 ndim, which is the number of dimensions, x3 dot ndim. We'll copy that down, we'll paste it here, and now we will just change these words. Here we will use shape, copy that down here. Now we will use size. Now let's print this. We got an error. We wrote the colons, double quotes, which was not needed here. That results in error. Let's look at the error. Here we have, sorry, my bad, I've written. So you can see that these type of mistakes can cause errors. Now we will run this and we will get the result. Okay, so another useful attribute is the D type and the data type of the array, which we discussed previously in understanding data types in Python. So now we will write print D type. We have to remove this as it automatically writes the double quotes to close that gap. x3 dot D type. I don't know why we are getting so much errors, sorry for that. So yeah, D type integer 32. Okay, so other attributes include item size, which lists the size in bytes of each array element, and n bytes, which lists the total size in bytes of the array. So now print item size. x3 dot print and bytes. Item size 4 bytes and n bytes is 240 bytes. So in general, we expect that n bytes is equal to item size times size. Okay, so now moving ahead to array indexing, which is accessing single elements. We will discuss this. So if you're familiar with Python's standard list indexing, indexing in NumPy will feel quite similar. In a one-dimensional array, you can access the ith value counting from 0 by specifying the desired value, by specifying the desired index in square brackets, just as with Python lists. So starting it off with x1, which gives the answer this one. Then we will write x1 in the square bracket 0. This gives the answer 5. Actually, I'm pressing shift plus enter to run, which is a shortcut of run. So x1 square bracket 4. This gives the answer 7. So to index from the end of the array, you can use negative indices. x1 square bracket minus 1. This gives the answer 9. Then we will write x1 minus 2. That gives the answer 7. So in a multi-dimensional array, you can access items using a comma-separated tuple of indices. x2. This gives the answer this one. And then we'll write x2. This gives the answer 3. Then we'll write x2 square bracket 2 comma 0. That results in 1. Then x2 7. You can also modify values using any of the what we have written that. Yes, so using any value of the index notation we used here throughout. Okay, so now x2 0 equals to 12. x2, that gives the result like this. Keep in mind that unlike Python lists, NumPy arrays have a fixed type. This means, for example, that if you have attempt to insert a floating point value to an integer array, the value will be silently truncated. Don't be caught unaware by this behavior. You can consider this a warning, like. So now x1 0 is equals to 3.14159. 3.14159. This will be truncated. This will be truncated. Okay, so now let's move on to the array slicing, accessing subarrays. Now let's move on to our next component.